hit the start recording button. Okay, welcome. I'm going to move this window over, and so I can see you guys over there if you raise a hand. And I got to share the screen, don't I? Present a window. I guess I can do just that window. Yeah, there we go. Let's see if that works out the way I want. If I go into present mode. Okay. Does that look right to you guys? It doesn't show me it. Does it show the After Hours Game Dev logo?
It does, yeah.
Okay, thank you. All right, so we'll go and get the meeting started. Oh, okay, a couple people moved in. Oh, okay. All right. Let's see here. So, let's see. Last. Well, anyway. So, welcome to After Hours Game Dev meeting. Glad to have you. I'm Lyle Shields. I'm your software engineer for Army Game Studios, and Nick's not joining us tonight. I don't know if he's fighting the storms. I know a lot of people are having quite a night. And I decided to go ahead and have the meeting anyways, just because, you know, I like to keep the schedule going. For those, everybody on out there in the world, that's me. We have Patrick Phillips. Patrick, what you doing these days?
I'm still a software engineer for aerobotics. I design robot systems and HMI solutions.
Okay, all right. And Harley, tell us a little about yourself.
Hi there. As Lyle said, my name is Harley. I'm a senior at the University of Alabama in Huntsville. I study animation, and I'm an intern at Intuitive.
Okay. And Chadwick, you're also joining us. I see you down there. Can you tell us a little bit about yourself?
Yes, my name is Chad Burton. I am currently on the market, so freelance right now.
Right.
But a 3D artist with the focus on Unity.
Okay, very good. Unity artist, very good. And then Ben, welcome tonight. Would you tell everybody a little bit about yourself?
Hello, I'm Ben. I like to make tiny little things, games, and animations in this thing called Pico 8. I probably won't be on a whole lot tonight. I had a 6.5 hour interview today with
Oh my
Blue
goodness.
Mammoth.
Oh, good. Well,
Uh, so I'm hoping to hear back from them in a couple days,
that's okay.
but I'm pretty pooped.
Yeah. It's 6.5 hours. Oh my gosh, that's long. Well,
Yeah,
congratulations on the process, having the interview process, and hopefully you'll hear
thank
good
you.
things from it. Jessica, hey, how's it going? You want to tell us a little bit about yourself?
Hey, yeah. My name is Jessica. Like Lyle said, you can call me Jess if you want. I'm a 3D character artist. I was previously at Intuitive for about close to 4 years, and I recently have moved on to doing freelancing stuff right now.
Okay, I hope that's going well for you. Um, All right. Well, we're going to move on back to the meeting. Thank you for introducing yourselves. With a smaller group, that's something I don't mind doing. With 30 some people, it gets a little long. But After Hours Game Dev Group is intended to be informative and present lessons to help each of us grow. It's supposed to be interactive, so we talk about these things. We don't just, it's not just a vacuum. And of course, we want it to be fun as you network and you meet other people. So today I decided that we would explore randomness, or exploring the RNG, as some people would call it. But how are we using randomness in games? And we've got three different presenters tonight. It's going to be first will be Patrick, then it'll be Harley, and then I'll follow up in the back end on this one. So let's talk about it. Patrick, you have implementations of randomness in level design. I'm very curious of what you got there.
Well, I'm not going to teach you guys how to make random levels in 10 minutes, unfortunately.
No,
But
that's okay. Tell
what
us
I
about
can
it,
do
though.
is what I can do is I can tell you about some of the shortfalls and some of the benefits of it. I forgot to pull up my notes. I am ready to go. It's not my notes. It's not my notes either. Oh no. Uh, anyways, I will present this now. Can I take over presentation?
Yes, you should be able to. Go ahead.
Window. Present. Share now. All right. So, in implementations of randomness and level design, So just see a few introductions. Why does it not let me go? Who am I? My name is Patrick Phillips. I'm a robotics software engineer employed at Aerobotics. I mainly work in C# and C++. I don't really do game development, but I've noticed that game development and robotics are actually strikingly similar, and especially as you start digging into the theories of robotics and a lot of other stuff, a lot of it will have commonality in place with game dev. So it's kind of interesting to read about that. So the big question we have to ask ourselves is, what is random level design or generation? And in reality, there's like a bunch of different definitions you can kind of throw at this, but the big one to note is that the idea is that there's some sort of set of rules, and you use random number generation, usually numbers, or you could use a deck of cards or something, to apply those rules to generate valid game states. So that is like the very high level idea of what random level generation is. Why should you use random level generation? Well, the best reason I can say to use it is this is something that's often cited, is that I myself am only one developer, and I might be able to pull on maybe one extra artist. But that artist is, let's say we want to make an RPG or something. If we want to make a level, our artist has to design intricate ways of things having to layer together. On top of that, I, as the developer or the artist, have to then design the mechanics of the game itself and design the layouts and the flow of the levels. That in itself is a very tall order and a very large workload for like a role-playing game or a turn-based game or something, right? So if you're limited on resources in terms of time, or especially for like art or representations of your game, random level generation is actually not a bad approach to go. You can have your artist be more focused on developing unique concepts such as like foliage, wall textures, enemy animations, or something like that, and less time concerned about how everything kind of fits together, and leave that up to the devs. There might be they'll have their insight, but ultimately it's about maximizing the use of resources what you have. The challenge is influencing random level generation. Well, unfortunately, a lot of people think, oh yes, I can just go to the internet and learn how to do this really quick. Well, the challenge is it's actually kind of I'm not going to say hard, but I'm going to say tedious, because you find yourself having to learn a heavy amount of algorithms and other things to kind of get the desired behaviors you want. So, for example, some algorithms are really good at generating cave structures, but not so good at generating maze structures. And some algorithms are good at generating city block structures, but not very good at generating caves. It's all in all, it depends on what you really want to do, and there's so many ways to slice this like cake that it's typically just pick your approach that you find that you like click with the best, and then move on with it, and then develop on it. There's a bunch of different ones you can look up here. Some keywords you can kind of throw up. I put quotes around ones I couldn't really remember the names of, but to give you a quick summary of each one, wave collapse is it uses the idea of like quantum mechanics, or a good example, actually a better example, is Sudoku, and how Sudoku usually has like 3 to 6 starting states. And then there's a set of rules and validations based on those starting states, what the actual final state can be. Drunken Sailor is pretty much, I'll show an example of that. Maze solving is implementing different maze solving algorithms to generate maps. Mine digging is sort of like the idea is that you can treat your terrain as like unmoved earth, and you can try to detect and scan for valid squares and dig out the terrain. Tile generator is something along the lines of Haunted House on the Hill. I don't know if you guys have played that board game, but it's along those lines. And cellular automata is another way of like generating decent cave structures and other things based on rules of ideas of living and dying cells and stuff like that. So you can have it's similar to wave collapse, in that there's only so many valid states that can exist in a cellular automata.
So would you say that's like the game of life?
Yeah.
Okay.
It's like Conway's Game of Life, actually. Actually, exactly the same thing as Conway's Game of Life, except you would have to make more interesting dungeons and other things like that. You would have to create your own set of rules that kind of follow the same idea. So I have a basic example here that I can show you guys. I'll stop sharing and I'll share my example. Okay. Where is present? Present now. A window. This one. All right, can you guys see this one?
We can. Go ahead.
All right, so this is WebGL Unity. I created a really quick example. I put a link up. I'm not sure if Lyle can put a link. I can put this link also in the
Oh, we see it at the top.
chat.
Yeah, just put in the chat.
So I'll do. I'll put that in the chat. Where is the chat?
You have to hit the people icon at the top, and then there's a chat tab.
And there's a link to that, and then and this is a really rough implementation. Just so everyone knows, I didn't make it auto expand. So like if you put width height, this assumes a square, and you start seeing this at arbitrarily large numbers, it gets kind of goofy and it might not render correctly. This is an implementation, a really basic implementation of Drunken Sailor. So if we say max width height of 30, possible cells 2. Let me put this on actually. Hang on, it's off the screen. As you can see, it's generating random structures pretty much.
So what is the basic premise of the Drunken Soldier? Or Drunken Sailor?
So the basic premise of a Drunken Sailor algorithm is imagine a drunken sailor, but instead of him being able to walk in, with 0 to 360 degrees of motion, he can only walk in 4 directions: up, down, left, and right. You kind of give him a max number of iterations that he can walk, and then you roll a dice and you say, is that number one that corresponds with top, left, right, or down? And you kind of just walk through your square, and every square that the Drunken Sailor touches, you activate. And then you have another series of rules that would go corresponding with it. So you can generate a lot of interesting structures with it. If you increase the size, you can actually generate. It's best suited for caves. I made a really simple one that converges really quickly to a solution. I can show you guys the source code if we have time to spare, but I don't think I do. I don't know, 3 minutes? Well, am I over already?
No, you're good. You got 3 more minutes.
Um,
So it walks in a random direction, and you said the solution is it just it's just a number of steps it takes before it comes to a solution, right? Or
yes.
okay.
So an example of how you can apply this is you can, I don't know, generate a level, and then you generate your initial board, and then you would fill these areas with walls, and then you would then pick another random starting spot, and then you would generate again, and then you would generate again, and again, and again, and you would have to come up with a way to link the rooms together, but you could theoretically create a fairly complicated dungeon structure and stuff like that. And you can also adjust the rules. So if you want to make something more biased towards generating a horizontal walkway, you can play with the odds of saying now I want to make a more horizontal hallway or more horizontal structure. I'm going to bias towards my left and rights, for example, and stuff like that. This is not exactly the most efficient implementation because it's not using a graph, but that's another discussion for another time. Mostly because graphs get kind of in-depth in coding, and this is just an array, and then I iterate through the array of all the selected items. So, and I believe that gives me a minute left. If there's any questions, I can take them.
Okay. Anybody have any questions? So one of the ideas I'm sitting here and I'm thinking of the old game Diablo. And each of the blocks in this example here could be like a room or set of rooms. So it doesn't necessarily have to just be open space, but it could actually be how the rooms are connected. And that is a very simple algorithm. And you don't necessarily you start in one point in the dungeon, and then you know every point is possible because the drunken soldier walked through there at some point. Drunken sailor walked through there at some point. So that's cool. Okay. So and as we see, as you clicked on that, we saw lots of different randomness or different interesting shapes, and that piques our interest. Cool. Okay. Any questions? Okay. Well, thank you, Patrick. That's a a good look at the the different ways that we can generate random dungeons, or not just dungeons, but levels and so forth. Um, with that, we're going to switch over to Harley. Harley, does this tie in? Does that what we just talked about tie into some of the interesting stuff you've been looking at?
It actually can,
Yeah.
absolutely.
All right, let's see how it links in.
All right, so I'm going to do a small demo on randomizing materials in Unreal Engine. It's extremely simple, but the idea can be used for a couple different things, which I'll get into in just a moment. Am I able to share my screen?
You should be able to.
Mhm. I think it's working.
Oh, yep, I see it. Go for it.
All right, so the first idea I had for this randomizing textures was for more environmental design. Specifically, say you had a beautiful library full of books, but you're like me and you're indecisive and you don't know what the book should look like, each individual one. So I'm going to help you guys create a very simple way to randomize that. So I'm going to, this is my little cute book model that I made for you guys. I'm going to import the textures I have for this book. I'm only going to start with 3. So the funny thing about this is that you can actually do a bunch of randomization inside the material. And the problem with that in my mind is texture samples are one of the most expensive operations you can do in Unreal in a texture. So I'm going to do this instead in a blueprint very easily. So I'm going to made one book texture, and let's just slap another 2 down here. Come on, Unreal, I know you're a little faster than that.
It's having this dream.
It is. All right, so I got some materials made. I'm going to make a blueprint actor. And random book is what I'm going to call it. I'm going to put in my model, a static mesh, and it's going to be a really tiny book. So let me make that just a little bit bigger for us. All right, and I'm not going to apply anything to it just yet, but I'm going to go ahead and put it in the world. My goodness, that is extremely small. It really does not like that, does it? Okay. Here is our beautiful, gigantic book. Here we are. Okay. So we're going to go into the event graph. And something you can do, I'm going to start with something really simple. It's going to change the material of this book based on a timer, but you can do it upon construction of this book. So I'm going to take my static mesh, bring it out, and I want to set its material. All right, so I'm going to plug that up. My goodness, I actually need to do a timer. Set timer by function name. All right, so I'm going to create a function over here. I'm going to call it change material. And this is where I'm going to take my static mesh and set the material for it. All right, plug that up. Now I need a way to hold all of my materials here. So I'm going to create a variable called material list. I want it to be of type material, and it's going to be an object reference. And I want it to be an array so I can have a list of items. So we're going to add a couple values here, and I'm going to plug in my materials, easy peasy. All right. So now we need to get our material list. And we need to randomize the index here so we can randomize which material is being used. So I'm going to go ahead and get the last index of this array, and it starts at 0. So we need to add 1. And then get a random integer. So I'm going to bring out from this array, and I'm going to get a copy from it using this random integer. And plug that in here. So now we're going to have a random material. So now I need to go back to my event graph. The function I want to call is change material, and I want it to loop. And maybe I'll have it on 0.5 so it doesn't go too fast on us. I need to get an instance of my static mesh and plug that into here so this timer knows what to affect. I believe this is all we need. So if I play this, live coding, everyone. All right. Maybe I don't need that. I think that's what that is.
It should be working.
It should. Let me look at my notes real quick.
Don't worry, everything breaks on demo day always.
It really
okay.
does. Let me get this version. It doesn't like something I did.
It's doing a random material, but it's setting
It
and
is.
material index is supposed to be 0, so that.
Okay. Alright, well, let me try the other method I had and see if it's just causing a fit. Alright, so I still want to...
Did you set the blueprint material correctly on your book that you created?
You know what? I probably did not do that. Material.
Yeah, that should work. The more I look at that.
Yeah.
Odd.
That is very odd. Yeah, I'm just going to try this other way. Static mesh, set material. And again, we're going to get our array. That's index. Add a 1 to it and get a random number. And plug that in. Oops. To get.
Hey there, Spencer.
Hello.
I don't know what it's doing.
It's just keeping the world grid material. How
It
odd.
is. Funky. Well, it's supposed to be doing what this wonderful plane is doing over here. I don't want to take up too much of her time.
It's okay. Did you have like a object previously made elsewhere in a different project? Didn't know
I
if that
did
was
not.
easier. Okay, no problem.
Yeah.
All right, so the beauty of this, I mean, we can see the texture changing on the right. For some reason, that texture is
Right.
just not being applied to the book object.
Mhm.
But you have a set of book textures. And so the beauty of it is that you can then put this, if we put it on the construction, the books could then be placed different sizes, different types, but it's the same object over and over and over put into the world, and it's going to randomize the books on that. Say, like if they're on a bookshelf or whatever, they're going to just randomize. In this case, when you load. So we can
Yeah.
definitely see that. I'm confused. It looked pretty straightforward to me, Harley. But you know how it goes. The best laid plans.
It's
So,
supposed to be straightforward.
yeah. Anybody
Yeah.
see it? Anybody? It's a test. Test time.
It is.
You
And
set
what's funny is
material.
that you could, instead of doing this with textures, you could do it with different elements of like different foliage, different items you want to pick up in the world.
Mm-hmm.
It won't randomize the position, but it can randomize what is in there to still give you a certain amount of control. So you can make random encounters, and just every time a level loads, there's just a little bit of element of surprise in there.
Well, you could certainly have like a bookcase object that
You could.
you then with all the books on it. I mean, assuming
Mhm.
you don't have a performance issue, you can then every time you instantiate that bookcase, it's going to have a random look to it. And in fact,
Right.
you could even seed that random number generator based on bookcase. The bookcase has a seed number, and then all the books will generate the same exact way each time.
Absolutely.
Yeah.
All
I
right.
kind of wish Leon was here because he implemented something similar, but he had I would call random vine and foliage generation on top of random building generation using bump offsets. But
Well,
he's
that brings up an interesting point. If your book had two materials, let's say like a logo on the front, you could, and maybe even on the binding, you could randomize that too with another texture, couldn't you? Yeah.
Absolutely.
So we just keep applying that, and on off we go. Okay, very cool.
All right.
All right, thank you, Harley.
Thank you,
Any
guys.
questions out you? Any other ideas or anything you want to talk about on?
I've not that I'm trying to steal thunder, but it's more of a just question. Have you ever messed with using procedural generation for textures, or have you always just kind of generated your own textures and stuff like that?
I've only generated my own textures, but that would be something I would be interested in.
I guess you could have different textures and then you merge them together. You can then bleed them using multiply and various other effects,
Yeah.
just like the logo on the front.
I linked a thing called wave function collapse. So I was just curious if you could probably think of a way to implement that in blueprints.
Ooh, all right.
So the notion is that if you can generate images by having sets of rules that define what a valid state is of the system. But
So it'd narrow in on a valid state. I mean, and that's some way what the AI type systems are doing is they are basically trying to match patterns that they see and learn in the environment. So this is a proper looking book. This is not a proper looking. This is a book, maybe not the best example, but a building. This is a proper looking building. This is an improper building, and they're just putting on more and more traits that match things that would be expected. But then they still randomize it on top of it.
And then you put a cat in a box, and it thinks it's a book, and you get one of those.
A cat in a box.
It's amazing what you can do to break those kind of classifiers.
Oh yeah, definitely. Okay. All right. Well, thank you. We're going to move on now. Resume your presentation. Resume presenting. Is that actually presenting my screen again? I don't know. I think it's presenting a window in a window, probably. Move that back. There we go. All right. So thank you. And I will move down to. All right. So I decided to talk about why everybody hates RNG. And it's a little bit of a tongue-in-cheek joke because it's blame it on the RNG, blame it on the RNG. Everybody hates it, and it's one of those situations where you can't blame the computer for being random, but we blame the computer for being random. Yeah. Or, I don't, so let me explain more. So let me go a little bit first into what RNG. Everybody talks about the RNG, but it stands for random number generator. But I always find it interesting. I have to admit, I've had this odd fascination with random numbers since being a very young kid who began programming. Is like, how is it generating a random number? It's like, what is it doing? And so computers are not random numbers, or they're not random. Everything about a computer, everything you're taught is everything's very precise, and they better not be, because if they are random, something goes wrong. So in some of the old computers in the old days, they actually did have there was hardware to generate white noise, and like even in the Commodore 64, we would use there was something called we'd actually use the sound chip, and to get a noise value, we'd also use a timer that was running really fast, and we get a noise value out of it. But it was limited. It do weird things when you least expected it. So a lot of random numbers these days are actually generated. This is the most simplest version one is they use a pseudo random number generator, which looks something like this equation, which basically boils down to a multiply, an add, and then a modulo. Well, A, B, and M are basically very large numbers, and a lot of times they're prime numbers to help ensure. So you're kind of like rotating through this super big combination lock, where if you just kind of rotate through and you multiply it. And so basically you get the next value is based on the previous value, based on this really large equation. And the numbers on these, actually, the bigger you can get these, the more random you can get. And because the way computers work and they're limited by a certain number of bits, you get this kind of round-around mapping of the numbers that occurs. So, if you multiply so many, on a calculator, it'll just say error at some point. On a computer, if you're using integer math, it'll roll over. 65,535 will roll over to 0 on a 16-bit number and go on. And effectively, that is kind of a form of a modulo of a 65 or 64K number. And they actually use a method, a very common method that's used on most computers, like Python is, it's called the Mersenne twister, which gives you this wonderful distribution of 0 to 1, usually floating point in a lot of systems, but or some very large number set. But anyways, the ultimate goal is to get 0 to 1, and usually and always it's normalized, okay? And what we mean by normal distribution is that the chance of getting any number in between the range, of course, most of the time is like really 0 to 1. This is just a graph I found. 0 to 1 is an equal chance that you will get any value between A and B, or usually 0 and N. You want it to be an equal chance of any two. So good. It's like rolling a dice. You expect when you roll one of these dice, you get a nice even distribution of basically 1 plus. You'll get a roll number that'll be 1 plus whatever the random sided dice is modulo. I'm sorry, the number of sides is n, and you have some random number, and modulos it with n, r being some large random integer, and you get +1. And you always get, if you didn't do the +1, you get like 0 to 5 for 6-sided, or you had the +1, you get the 1 to 6, which is what Harley was doing. No, that was a different case. Okay. Anyway, so you get this nice random distribution. And so that's how you usually make dice out of random numbers. I mean, there's nothing to it. But people really kind of actually hate uniform distribution. And this is, just because it's random doesn't mean psychologically we like this randomness. So people hate uniform distribution. There's, 1 out of 20 times if you roll D20, you roll 1. 1 out of 20 times you roll D20, you roll 20. If it's, if it's 1 out of 20, you roll a d20, you should get each of the values an equal amount. On average, you might get 3 7s in a row, but over time, it should average out that 7 became less and less. And, that gets in the world of statistics, and I'm not going to go into that, how far do you have to go before that's the case. But anyways, so, and the point is, if you have to just roll a 20 on a d20 to win a game, your odds are pretty low. You're going to not a very good game. So obviously people get around this by buying lucky dice, and every D&D player has a bag full of lucky dice. because they want to somehow work that distribution to their favor. So they roll those 18, 19, 20s higher, improving their odds. So, I mean, but we sort of, and even then though, for some reason we still kind of hate math, or I mean, we hate randomness, and it's because people don't really quite do the math and they don't quite see it. And I don't blame them because it is kind of hard to see it. If you ever played XCOM 2, a great game, by the way. It's a great strategy game. You will find yourselves cursing at this game for what seems like the most inane times. You're like, how the frick did I miss? So you hear this picture over here on XCOM. You got a 98% chance here that you'll get a shot with he's firing a pistol, and then the game actually tells you have a 98% chance of hitting, and you miss. It's like, how in the world did I miss? Okay, and you'll be like, and this will happen what seems like at the worst times in XCOM, and that's always the fun part of that game. But it's a 98%. But when you do the math, you say, well, 98% chance to hit. There's a 2% chance to miss, which means 1 in 50 chances to miss. So if you're doing this 100 times in the game, there's going to be 2 times you're going to miss that great shot. And they're all great shots, of course. So you're going to be, so of course your brain wants to remember the outlier when you miss as opposed to when you hit, which you assumed was going to be natural and out of your mind. But if and then this just gets a little bit worse. You drop that down from 98% to 90%. That's a 10% chance to miss. That means 1 in 10 chances you're going to miss. And if you have 100 times in a game, 10 times you miss a great shot. Because you think 90, if I can hit 98, I can hit 90, whatever. Psychologically, people are wired to be angry. It's so maybe the flaw is because we show them the number in the first place. I didn't think about that when I put this slide together, but I'm thinking about it now. So, the problem is our brains aren't quite wired to do that math. 80%, I mean, it's 1 in 5, so forth. So what we can do to probably kind of help people a little bit is we can add a filter to the RNG. We can make it a little less random. It's random, but it's not as random. Take a good old D&D example, your old 3d6. We got a d6 plus a d6 plus a d6, and somehow it kind of comes out to this curve where you'll get 10s and 11s the most, and 3s and 18s the least. And you get this distribution that somehow our brains can actually comprehend a little better. We're filtering it. And so people say, well, the expectation is you're going to be in the middle there somewhere. When you really have, what do they call the binomial curve? Anyways. But the point here is psychologically, we find that people are, because it's more predictable, you have a happier outcome. They might be a little more disappointed they keep getting these numbers over here, but it's a real joy when the one number comes up high. And there's this disappointment on the low side, but it seems like it happens less and less and less. And so the odds of a really disappointing one is really out there. So, and then we can still do a lot of things. If we can shift that curve around, we can kind of give them a +1, +2. This is just kind of an example, very rough example, but you can shift that curve around by changing the math slightly, add a detail here, drop the lowest die, so forth. But honestly, if I was a programmer, I would use a table. If you really want to have the absolute control, take a table. This is just a rough table. This is just a rough example I gave, but and then we've used this for loot drops for ages. It's like, oh, okay, there's a 30% chance there's a drop, 20% chance that'll drop, so I'll give it 30 slots, I'll give it 20 slots. And the beauty of this is then you can have absolute minute control over that curve. That curve can be anything you want after you do this, and you're just basically setting the odds for entry. So you just say, all right, 2 to 5, that's 2, 3, 4, and 5. That's 4 out of whatever this table length is, and 6 and 7. So that's half as likely that's going to be, and then 8's going to be half as likely as that. So we have a very simple relational element on figuring out what is the possibilities, and we can load the dice effectively for the player. Here's some loaded dice. It'd almost be like saying when you roll a d20, if you roll a 1, it counts as a 20. You can do things like that. I mean, you can change those rules. So you can mess with the filter so that you can get a more positive experience. As other games do weird things like what they call exploding dice, but I won't get into that. um, but we can also we can take this even to the next step. So I worked on a game called Storm Wars, where it's a collectible card game, and you would open packs of cards every so often. You'd get enough coins, or you just pay for them, and you'd actually get a pack of 5 cards. We'd open, and then of course they're random. They're just totally random from a random number distribution, and in this case it's just common card, common card, common card, common card, rare. Okay, this is obviously a very low end pack. But we had players complaining about this. The RNG sucks. The RNG sucks. Why am I've opened 20 packs and I haven't gotten a single epic or whatever. Like, and the odds are 1 in 20 decks I should get an epic. Okay, well, we have to remind them, well, it may not be the 20th deck. It might take 40 or 60, decks before you can get that epic. Doesn't matter. Players, it's again that psychological element. It's not the randomness. It's the psychological expectation that, hey, I'm special and I want my epic card. So what we did in Storm Wars is we actually gave in. We changed the filter. We put in what we call the pity timer. So after 30 packs, if you haven't gotten an epic, here you go. You got an epic. And whenever you did get an epic, we reset that counter. So you were at least guaranteed to get an epic every 30 packs. So yes, just it messes with our distribution some, but it really made the player base a lot happier knowing that no matter what, after a certain point, they were going to get something of value out of it. This is different, you ever heard how Magic the Gathering does their booster packs? They actually basically take big sheets of cards, and they have like 100 cards on a sheet. I don't remember. And there's like 2 that are super rare. Or they're rare cards or something like that. And then they actually cut up the cards and they shuffle it up a bit with a certain number of them. And they have a very strict distribution. The distribution is precisely that. And even though our numbers are precisely at that distribution, there is something about uniform distribution. There may be a chance that it'd just be like a really long time before you get that. Whereas if you bought a whole box of booster packs from Magic the Gathering, there's a pretty darn good odds that they were shuffled well. Not perfectly, but anyways. Again, it's just a game. So the key I want to take away, it's just a game, and unless there's money really involved, and even in this case there was money, it's still okay to give the player something every so often. And in this pity timer, we basically said when the odds got to a certain point that was kind of ridiculous, we'll take care of you. Okay. The other thing that random numbers sometimes do on us is they sometimes make things unsolvable. so like Klondike, have you ever played a game of Klondike and you got to a point like, I don't think this is a winnable hand, and you wasted time on it. Players will go nuts trying to figure out, we'll get to a certain point, and if they find out that you wasted their time with say an unsolvable maze or a Klondike deck that card game that could not be done at all, they will feel like they wasted their time. There's disappointment. So what we can do is have the computer play it and validate that it's correct. I mean, mazes typically have an algorithm that solves that, just like you're saying before, that's already kind of designed. But I've seen some really bad maze programs. It's like, oh, you just put me in a corner where I can't ever do anything. But some dungeon builders in beta can do that too. But yeah, so even Klondike, you'd think wouldn't it be that way? So I mean, you might say then, randomness is the obstacle sometimes, and what you can then do also is maybe, even if you do have a super random setup like this board game, you can give the player powers to control the board and change the odds. There's various cards in this game. This is called Shadow Hand. It's made by Gray Alien Games. I loved it. It was like a role-playing game with cards at each level, like each combat. And you could hit these cards down here. You power them up by doing certain things, and you could hit these cards. In this case, I think the hand here would shuffle all the cards. Real simple, and it would do a pretty good job of allowing you to get further in the game. Only problem, just side note, only problem with the game is they did get the decks got harder and harder and harder, and it got to the point where if you didn't do enough early enough in the game, he really balanced it so well that it got really hard, and so he actually had to bow to adding a continue button so people could actually get through the story. Otherwise, they would get stuck. Anyways, that's irony is he worked through all the randomness. It's a really interesting game for how he made sure the game actually flows really well too. Oh. But I want to also put a word of warning though. If you get too much randomness going in a game, let's see here. Oh yeah. Sorry. You can actually have sort of problems. I see this all the time, and this is a little bit off topic, but I'm going to go ahead and put it in there. You see, like items. This is an item and a legendary, I guess, if I remember correctly. I do not know this particular item. I just used it because I had a good example here. But you can get items in games, and they just keep adding more and more randomness, and they make the epic items, have four, or they'll be like the epic item has three things, legendary has four, the art, ancient artifact has five bonuses, and you get to a certain point where all your items have plus six, plus seven different stats. They all become the same. And I know that you say, well, not quite, but yes and no. The thing is then you now just worry about the level of the item, and nothing unique or particularly powerful about the item is there. And the problem is like if I always, if I have only 8 different stats I can increase, and I gave you 7 of them in this magic item, that only leaves one item that didn't get in it. So now there's only 8 different types of objects. Because it's 8 different stats that didn't get into in the 7 listed stats. I'm using a very extreme example, and so your filtering, your randomness now just becomes who has the highest numbers, and it all collapse. It's kind of collapsing in, and everything's kind of becomes the same. I see this in a lot of games. I've seen this in Borderlands. I've seen this in, of course, World of Warcraft had a certain amount of that. They're not as bad as some, but they're still there. Um, the Division 1 and 2 both have the same problem. You just get to the point where everything is just blah, the same. So I would advise, try to make everything filter in a direction. Don't just filter it, or just don't just keep adding randomness, because otherwise the randomness itself becomes its own filter as it overlaps. Okay, and one way that you can resolve a lot of that is you then a lot of this is what happens in a lot of games. Borderlands 2 and 3 did this. You start getting unique drops, which are they're just unique. This gun has special abilities that no other gun has. Well, that's great. I mean, but there's like only 30 of them in the game, so you're kind of back to where you were. Why not just drop one of 30 items, and then have different levels of it. Okay. So, anyways, I'm getting a little off topic, so I want to go back to it. So, players really, they basically don't like random when it's just kind of forced on them. They have no control over it. So, to help with that, feel free to use tables and not just straight up randoms, but actually put some thought in the weighted distribution of what you're randomizing, even if it is. Loot table is a great example, but there's other cases, even in combat scenarios, such as, even the crit 20 in Dungeons and Dragons is a great example where you've messed with it. It doesn't matter if you did or didn't have really enough stats to get it. You get an automatic hit. I recommend also just focusing a little bit more on the unique and have actually smaller random variations. If you get too many random variations, they overlap, they mess with each other. Cut it down. And then, of course, when you can, give the player agency over when they have randomness. Let them control some of that somehow. Even if it's a potion of luck, or just choosing when the randomness is being used, let them do it. And by all means, even though that sometimes is seems like you're losing something, it still puts fun over just random variety. So it lets them be a part of the filtering process. Okay. So anyways, that's my overly long talk there. Sorry about that. Did anybody have any questions or ideas they'd like to discuss about that? Okay. Sorry to ramble on so long.
I really like the table idea instead of doing random numbers.
You like that? Yeah.
Mhm.
Granted, not every case works with that, but it definitely gives you all the control. And programming wise, it's really not much harder. Yeah. You don't
That's
have to
kind
get.
of already how it works under the scenes, isn't it?
It depends on the project. If you it depends on what you're doing. If I have a chance to shoot somebody, I can change that based on the type of creature and the weapon being used, as opposed to just being a straight up stat.
So a good example of designed randomness is for those of you familiar with D&D is the 3 point version 3.5 versus just 5. I'm not sure how many D&D veterans we have in the chat.
I think there are.
I'm not trying to point out anyone's age. I'm specifically mine. I played 3.5. That was my starter one. But the whole point is in 3.5 the RAM just did not feel good. Mostly because people figured out ways to cheese the system and enable people to just hit things guaranteed, or they were meaningless in an encounter. And then WotC kind of designed encounters such that it was almost mandatory to do so. I'm not sure those of you heard, but there's like the whole linear fighter versus the exponential wizard example, right?
Mm-hmm.
But they kind of fixed that in 5e by doing what they call I can't remember what they called it. Bound accuracy is what they called it, and what they did was they flattened essentially the power curve of what people could do in the game, but they also increased the amount of dice that people throw. So statistically speaking, if your character is good at something, like for a skill or hitting people or doing something like that, you are likely to hit at about a 40 to 60% chance, with the high end being 70 and never being over that unless it's like overwhelming encounter. So what ends up, and then there's also the concept of advantage and disadvantage. So what it turned out WotC did is they focus in like people like throwing dice. We should just give them more dice. And they probably didn't say that explicitly, but it's what it feels like after having played a lot of 3.5 and 5e. Is that they like their players hitting things and being meaningful in combat encounters and stuff like that. So
So
giving more people more things to do is always better.
So by adding another die, just like the 3d6 example, if I had 4d6, yes, the total number goes up, but the curve is still pulling me. How should I say it? If I add another d6, I'm still adding a 1 to 6 randomness. I'm not always going to get, for lack of better words, it's not just a plus 3.5, or plus 4. There's still randomness on the result, but it's still a bonus. So in other words, you don't always go to the high end.
The advantage disadvantage thing, because the probability is set around 30 to 70%, where it's more of like a normal around 50 to 60, is that gives it essentially means they're skewing you towards either hitting or not hitting, but like it's really subtle design
So something
choice
like
there.
like the screen I'm showing right now.
Yeah,
You keep skewing it. You get closer to the high end, but you never quite hit it. That's your 70% case. And then of course the difficulty is going up on the other side too, on what you need to hit. I don't know. Okay.
All they do is shift the mean.
Yeah.
That's all they're doing in 5e is by shifting it and designing your encounters appropriately. Your average hit chance basically is the same, but you can still occur the random cases of the exciting moments when you shouldn't hit, but you do hit. Vice versa, the I should always hit, but I somehow didn't hit this one time, is what D&D is designed for, though, because it's that response from the failures or successes that are unexpected that kind of
Right.
drive the D&D experience.
Okay.
and if you want to do more, I actually would say everyone should probably play tabletop RPGs if you don't, or at least look into them. There's a lot of interesting takes on random numbers and how to use them in game design.
Yeah, definitely. Okay. All right. Well, with that, I'll close out. And I want to point out there's a couple events coming up in April. The Hatch 2021, that's the Hudson Alpha Technical Challenge, is coming up. That's going to be held virtually this year, of course, due to COVID, but they are going to still hold it. And there's a link to the web page if you're interested there. The interesting takeaway I got on is they're doing it like daily. So there wasn't a whole lot of details on the webpage on what that means. So I'm guessing what that means is you sort of sign up for the day that you can actually participate in the event, and then they'll just keep doing it every day. So yeah, there's a lot of days there, 16th to 25th. If you're interested in that, certainly take a look at that. Additionally, just a quick reminder, Lunum Dare 48 is coming up on April 23rd, 26th. You can actually do both of these events if you time it right. Just a reminder, I mentioned it last month. But okay, so this concludes our meeting for tonight. Hopefully nobody had any problem with the storms, but appreciate everybody for being here. The next meeting is scheduled third week of April, which comes out to be April 21st. Again, 7 p.m. Online, and I meant to change the topic. Whoops. Okay. And I forgot to put one down. So we'll, if you guys have a topic you'd like to talk about next month, please let me know, and I'll put that in the announcement. I was kind of going with the April showers, but I couldn't think of anything. April showers, May flowers, but I couldn't think of how that. Maybe we could do weather effects and so forth as an interesting topic.
I can do something on networking if somebody wants to.
Networking?
If that's of interest to anybody.
Sure.
I was also going to suggest time allocation strategies on game design, because like April showers bring May flowers. Because the idea is you do a lot of the grunt work up front, but you pay for it by actually getting a successful project later.
Okay. Yeah, Ben also talked to me about. I mean, you've got a particular area of networking you're also talking about. Is it Pico 8 related, or is it something else?
No, it wasn't me who said that.
I'm sorry. Who said that?
I think it was Spencer.
Oh, I'm sorry.
It was me. Yep.
I was looking at the pictures. Okay. Yes. Yeah. You have a particular area, Spencer, that you're looking at of networking? Just curious.
No, if whatever people are interested to hear about.
Okay. Yeah. No, that'd be cool.
If there's something specific, I can tailor it one way or another.
Okay. All right. Networking and time management. All right. Okay. Well, thank you, coming. As usual, check us out on the Discord boards or talk to us on Facebook. I'm going to end the recording, and then we'll go to the second half of the meeting. Thank you.